guys. So my name is Karthikeyan Sankaran, Karthik. So what I will do as part of this talk, right, is to kind of give you, so we are kind of zooming out a little bit from what was the previous session about. The previous session was about a very specific area, right, recommender systems. What I will try and do is to kind of zoom out a little bit and talk about, given the fact that there are so many things that are happening in data science, right, how does one navigate through the whole space, right? And in some sense, this is a personal thing that I have kind of developed, and again, it's not perfect, of course, but it kind of helps to have a view in terms of what are the different areas, how do I navigate through this, how do I collect information, join the dots, right? That's very important in the data science space. That is what I will attempt to do here. Again, my intent is to take some of it and then say, you know what, I have my own way of looking at things, and you have your own knowledge map of sorts, right? And if this helps you in some way to develop that map, so that's basically the intent. Okay. So what I will do is I have some slides, but in essence there are only probably I have a half an hour. I'll skip through some of these slides very quickly, right? In terms of why analytics, I think all of you here on a Saturday morning are here because you understand why analytics is so important. But just one thought about the whole thing is very fundamental, right? Because there is a digital shift that is happening, there is so much of data that is kind of coming in, and technology power is increasing, it's unlocking new business cases. So it is not a fact, right? It is actually there to stay because the digital shift and the data deluge in some sense is very fundamental, right? So if somebody says, should I invest time to build a career in analytics data science? I think the answer in some sense is yes, because of this fundamental shift, right? So I'll start with that kind of a preamble, right? If there's one thing that you would read to get inspired about where data science is headed, I would suggest this, right? A McKinsey paper. They published this kind of the age of analytics, competing in a data-driven world. I think they publish it every year or so. The last one was published in December 2016. Take a look at it, because not only does it give you the range of techniques that are possible in data science, it also tells you the industry-wise breakup, right? What is more applicable in certain industries and all that. If not for the details, I think you'll definitely get inspired by what all possibilities exist, right? So, in terms of the broad dimensions of analytics, again, the way I kind of see that, I mean, it will be more clear when I kind of get to the mind map of sorts. So I've developed a mind map, right? There's around 2,200 odd nodes right now. It's on the web. Completely free, anybody can take a look at it. Again, the intent is to say analytics is a very broad area, right? People tend to think of it as like, okay, is it only data science and machine learning? No, there is data management aspect to it, there's a business context aspect to it, there's a reporting visualization aspect to it, there are many different aspects to it. So you might specialize in one area, but it's very important to have a good feel in terms of what are all the broad areas, right? So this mind map, again, for this talk, I'm not going to focus on this mind map, but that's available out there. I'll quickly show you what this mind map contains, right, so that you have a view when you navigate through that. So this is basically the mind map, right? Hopefully that is kind of visible. So on the left here, you get all the business areas of focus, right? You need to understand what is the business model, how do companies make money, right? And if you're really a domain person, understand what the different aspects of the domain are, right? Banking, financial services, insurance. What are the different use cases from a domain standpoint, from a functional standpoint, right? What do you mean by a customer intelligence use case, right? Or a set of use cases in customer intelligence. How does a supply chain intelligence use cases look, right? So it's very important to understand that context, because without that, analytics has a big disconnect in terms of how you can implement it. So that's the left-hand side. The right-hand side portion of it on top, right? These are all the different, I would say, technology data map kind of areas, right? So one talks about how do you build those kind of data management platforms to manage all that data, because there is a lot of volumes of data, it's kind of streaming in different types of data. It's not anymore this transaction, right? There is a lot of different stuff. So how do you manage all of them? It starts there. It goes down in terms of saying how do you do reporting, visualization, because those are descriptive kind of analytics, diagnostic type of analytics. That is also important in a lot of context. Then it gets into the third piece, is what we normally focus on as part of this talk, which is about leveraging the kind of quantitative techniques that are available, right? For what kind of problem, what kind of techniques are applicable, and why, right? How do we kind of look at that space? That is what will be the focus of this talk. But I just want to give the broader context in terms of data science or analytics. I would say business analytics is a fairly broad area of it. Data science is a very important part of it, right? So There is a lot of depth in this. As I said, there are 2,200 nodes here. Just to give you a sample of some of those, right? So it talks about what are some of those interesting projects and GitHub repositories, right? So just to give you an example, right? I'm not going to probably once. So I've listed down what are some of the key open source libraries that are there, right? And it links you to the GitHub, right? Keras, TensorFlow. There are many different platforms like that. And when you get into the data part of it, right? So there are aspects around data management, which is very important for people to know. So let's say you look at this node, and then you keep clicking on this node. It gives you a lot of details in terms of what are the different areas of data management. How do you do data classification? What are the different types of data architectures? What are the package applications? What is data integration? What are the tools spread in terms of what it is, are collected from multiple places. But the idea is very simple, that you will go here, take a look at it. This does not have depth, right? This only has the depth. And so you will get what are the link to Wikipedia and your own courses and stuff like that, right? So what I will focus on now, right, as part of this talk, and so this is publicly available, it's there in the slide also. I've given the link for it. You can take a look at it when you have some time. What we will focus on is basically the whole navigation piece, right? So the context is, okay, we understand the broad areas. Now we are coming down to talking about what are the techniques that are available. So we are talking quantitative techniques, right? So what is the right way to start? Because you keep hearing a lot of things. You keep hearing all the machine learning stuff. You keep hearing artificial intelligence. Suddenly deep learning comes into the mix. People say now hardware is such an important area of machine learning. Spark, scalability. So how do you kind of put it in context in some way? Again, as I said, you can form your own way. But this is my way of thinking about it, right? So the first starting point, at least in my mind, is, so what is the focus of this analysis on, right? Is the focus of analysis on data, right? Or is it on the system? When you say system, it is basically not just the data alone, it is the data generating system, correct? So for a typical machine learning guy, right, he starts off with a data set, he or she starts off with a data set, okay? You typically don't have too much of a view or an interest in understanding how was this data generated, and more often than not. You're saying, I have a data set, yes, it could have a label, not have a label, I'm just trying to understand something with that data, right? I'm not really bothered about the data generation process. But there are cases where the system and the data generation process is also very important. So we'll talk about that a little bit. So that's the second part of it. The third part of it would be pure focus on process, right? It's not enough to get data insights. There are many cases in business situations where you get process insights, right? Machine learning will never help you answer the question of machine learning in the classical machine learning sense. Will never help you answer the question of what is the bottleneck in my process specifically when a purchase order thing is being generated, purchase order cycle happens, right? What is the bottleneck, right? Which resource is the bottleneck for me? It will never answer those kinds of questions, for which you need a slightly different range of techniques called process mining as opposed to data mining, right? So the focus is on the process there. So we'll touch upon 2 and 3 a little bit, but since it's a data science meetup, right, I want to focus on the data part of it more, okay? So can you guys see this? I'm sorry. Is that fine? Okay. So when you start saying, okay, the focus is on data, okay, that's a starting point now. What is the next question? Next question is the data structure or unstructured or semi-structured. I'm kind of leaving out semi-structured for time being because semi-structured can be converted into structured data, right? Semi-structured, it's just that it does not have a schema, but it has enough inputs for you to really kind of translate into structured data. So let's look at it as 2 parts, structured and unstructured data. And the simplest thing to understand is structured data because we've all been seeing transactions, systems, tables, rows, columns, etc. We fairly understand intuitively how a structured data should look like. Structured data by definition has a schema associated with it, right? And the easiest way to imagine that is tables, rows, columns, right? Or if you're a Python guy, it's like a data frame, right? So that's the structured data. So you start there and say, okay, in the structured data, is there a label present, right? Which means, does the structured data have a label on which you're going to try to predict something based on for that label, correct? Which is the dependent label. So once you get into that particular space, okay, if a label column is present, right, then you are getting to category 1. So as part of this, I'm going to talk about 10 different categories, right? I'm just giving you the overall picture. 10 different categories. Category 1 to me is supervised machine learning on structured data. Right? Now, once you fix that, then you are starting to think about what techniques are applicable in a situation where you are doing supervised machine learning, right, on structured data. Right? So then you start clicking and saying, okay, the first thing that you would look at is the label column continuous? If the label column is continuous, it's a regression column. Right? And I'm not getting into again the details of regression. There are multiple types of regression and things like that, which is there in the other mind map. But suffice to say, structured data, you have a label, the label is continuous, you are talking about regression. Right? If the label data is categorical, it could be binary, it could be multi-class classification, multiple classes, then you are talking about a classification problem. Right? As simple as that. There is no other thing that comes into the mix when you are talking about structured data supervised machine learning. Right? But you could have a range of techniques. So, and typically how you build, and this is just an example, you could do it for all things, right? So, what you do as you keep practicing different things around, okay, regression, classification, structured data, you start applying it, right? You will have some hands-on stuff. You will have to start building a recipe, right? So, this is my recipe in terms of how you handle it. What are the different steps to this problem? When I say recipe, there's an underlying code to it. Different parts of the code do different things, but what does it do? This is what it basically does. You load the library. So there's a Python-centric recipe, but you have your own R-centric recipe and all that. But your recipe essentially has to do all these things for you to arrive at the final prediction, regression in the case of continuous, classification in the case of a classification problem or a categorical data. Right? So you start by loading libraries, then you start defining functions and variables and dictionaries for you to map stuff. Right? The third one is you load the data sets, of course, training and testing data sets. The fourth one is you understand the data, and there are multiple parts to understanding the data, but the most important thing is visualizing it, right? Descriptive statistics, you do some statistics on it, you visualize the data. Basically, you are investigating the data to understand what do each of those features mean, right? Of course, the numeric nature, the categorical nature is important, but also an intuition in terms of how is it going to affect your variable, which you are predicting, right? And this is a science by itself. There are lots of interesting stuff, lots of interesting notebooks. The best place I would suggest is go to Kaggle, right? Kind of register in any competition and then look for the kernels that people put out, right? It's extremely good in terms of you get a complete view in terms of how people go about looking at the data, understanding it, to figure out, to get an intuition. This is all about, now we are not doing anything, right? You're just getting an intuition in terms of what the data is, how is it going to affect your final output, and things like that, right? So, and very important part is visualization. So, you need to have some visualization tool. It could be a BI tool, or it could be there are multiple packages in Python, R, and things like that, which will help you to visualize multiple things, right? So, after you understand the data, then you do what is called as pre-processing the data. Okay. There are multiple steps to pre-processing. Again, I don't think I have the time to go into each one of those steps, but suffice to say, this is probably the most important step when it comes to figuring out or increasing the accuracy of your models and stuff like that, right? People tend to focus a lot more on algorithms, but this is really the secret sauce in terms of if you can handle your outliers correctly or missing data correctly, right? And if you can do feature engineering, which means feature engineering is generating new features out of the existing things that are available. Basically, you're trying to create enough signals for the model to do the predictions appropriately, right? And so it's a science as an art. Also, science is some of those things are fairly standard, right? For example, if you look at a distribution of a numeric variable, if it's skewed to the left, skewed to the right, what kind of transformations do you apply? You apply a log transformation, a cube transformation, square root, whatever that might be. That's the science part of it. But feature engineering is a little bit of an art to say, okay, if I divide this by this, will the ratio be a better indicator of this particular output variable? Right? That's an art. In some sense, it also has some domain knowledge kind of built into it. So dropping unwanted columns. So the way this is the recipe, but then the important pieces are around how do you transform your feature columns. How do you transform? So people who are doing data science might have heard about this one-hot encoding, right? Things like that. So categorical variables have to be treated in a certain way for you to start applying your models. It's very important. Otherwise, the models is going to throw out rubbish, right? And in the case of machine learning, one lesson is if it's garbage in, it will be fantastic garbage out. Just love the output, but it's completely garbage. Right? So it's very important that you have a feel in terms of how you go about that process in a very scientific and a methodological So I will leave it at that, but at the end of data pre-processing, you are basically coming out with a set of feature variables, right? And your target variable. Target variable is what you are predicting. Feature variables are all the features that is going to help you do the prediction, right? That is what you end up with at the end of data pre-processing, right? Just let me know if I'm going too fast. I'm just trying to compress a lot of things into a small thing. Yeah. So then you do feature selection, right? Feature selection is very important. So you can do feature selection in kind of two ways for people. That's what they say. One is you can run the models and then do a stepwise kind of a regression and things like that to eliminate the features that don't contribute to the output. That's one way of doing it. But there are many cases the data set is huge. If it's a very large data set, you cannot afford to let the model run and then keep reducing your variables. So you need to have a method of doing feature selection upfront, right? And there are again many methods which will help you to say, if I have 25 features in my data set, what are the 10 most important features that helps to predict my target variable, right? That's essentially the feature selection problem. There are multiple ways of doing it, and I will kind of leave it at that. These are some of the things that are available in Python, right? So if you are a Python guy, XRDs, low variance, ECAs, RFEs, you will have packages. You just feed your feature data set, what you get out, and you have hyperparameters by which you can say I need only 5 features, I need 10 features. It will basically give you all that, right? So that's feature selection. Then you start comparing algorithms, right? You run multiple algorithms. So at the end of feature selection, you have the X, right, which is the features that you're going to use to predict the model. You have your Y, which could be categorical, which could be continuous. After this, I would say it's a brute force method, right? Run all the algorithms if you can. If your data set is fine or you have a good enough hardware infrastructure, you can run all the algorithms. Then there are ways to compare algorithms, right? There are standard metrics, so you need to do something called A4 cross-validation. You will have metrics, higher the metric, lower the metric as the case might be, might tell you this algorithm is better than the other one. So you'll have multiple ways of figuring all that out, right? And that's the comparison of the algorithms. Then what you do once you've selected the algorithms, right? It could be just one algorithm in some case, or it could be multiple algorithms, right? And so once you've selected them, then you do something called algorithm tuning, right? What is called as hyperparameter tuning. Because most of these algorithms will have a lot of these hyperparameters, right? It's a very tough thing to name simply. These are parameters for the algorithm for it to run better, right? You need to have a way to get to the right parameters, and there are ways to do algorithm tuning. Then you finalize the model, right? And when you finalize the model, as I said, it could be one model or it could be an ensemble, right? You could combine multiple models together, and when you combine multiple models together, there are ways to do it. There is something like stacking, there is something like bagging, all those stuff you can do, right? To bring models together, the idea is that a combination of models in some cases tend to provide you better results. But having said that, it might suffer on interpretability. So it's always, as a machine learning guy, you are always, there is a trade-off in some sense between the accuracy of the model vis-a-vis how easily it can be interpreted by your end user or the business user. So you're always constantly kind of evaluating both. And so in competitions, if you look at the Kaggle analytics with that type of competition, people use XGBoost, right? They get some fantastic results and all that, but it's a little difficult to explain XGBoost to a problem because it's a black box algorithm. It works fantastically for competitions where you really don't have to explain it to people, but in a business setting, right, it's very important to kind of explain, you know what, this thing predicted this value or this class because of so and so reason is the way you can make a business user trust your models, right? That's very important. There's a lot of research that's happening in that space also. Okay? Then of course, once you get your algorithm tuned, everything is kind of set, you have the different models, your ensemble, individual model, then you use it on the test set, right, to do the final predictions. Okay. I just went through this a little more elaborately because that is what I call as a recipe, and the recipes are there for every single area. Okay. So I'm not going to touch upon any of the other recipes when it comes to unstructured data and all that. I don't think I'll have the time. But this is how you kind of build out a recipe, and it is very useful. Believe me, once you have your own recipe, kind of running it on new problems is fairly easy, right? And when I say recipe, I have a code which basically is feature selection done. Give me the input and I will get you the output, right? That's a piece of code. I just copy it into the real problem and it basically works. And you keep constantly refining it, go back. Somebody would have put out a fantastic way of doing feature selection in a different way, right? You incorporate it in your recipe, and your recipe is your IP. so to say. So I'll leave it at that. So what we have seen is just one category, right? I probably have 10 minutes. So what if the label column is not present? We are talking about category 2, right? Which is about unsupervised machine learning on structured data. You have structured data, right? But then you don't have a label column. You are trying to understand some structure within the data, and that falls into the realm of unsupervised machine learning, correct? And so in the unsupervised machine learning case, some examples, right, are clustering is a very classic example, right? You're trying to find, again, as I said, structure in your data. You don't need a label column. That's clustering. There are multiple clustering techniques. Anomaly detection is a classic case, right? Where you detect anomalies, you don't need labels. You're basically saying, given a data set, which row or which set of rows are anomalous, right? Useful in a fraud detection kind of problem. Spoke about recommender systems. That's again a case where it's unsupervised structured data. I recently found the self-organizing maps. It's a very interesting area. It uses deep learning behind the scenes. But the kind of output that it provides on large data sets, where it can automatically self-organize and remove the outliers, is again a fascinating area when it comes to getting kind of understanding some structure in your data. Right? So that is category 2. So we have seen 2 categories, and so this is fairly straightforward, right? I pulled out another category 3, right? And I did that because time series is a very different thing. I mean, in some sense it is supervised because you are predicting some sales forecast and things like that. So you do have a label column for you to predict. But if you treat it as a classic machine learning problem or a classic regression kind of a problem, it might not work, right? Because the difference being that in time series you really can't, I mean, there is dependency between the different rows, right? In aspect of time, right? So you have to look at it a little differently. So category 3 is how do you do time series based forecasting or time series analysis or machine learning on a time series based data. Right? So if you look at category 3 and then you look at it, so there are classic time series analysis and forecasting methodologies, right? You must have heard of ANIMA, cold winters, like that has been existing for ages, right? Which are classic time series forecasting techniques. But what has happened recently is that there are new things that have come up, which is increased accuracy of time series forecast and time series predictions. So in our work, right, so we encounter a lot of situations where companies have been using forecasting. Forecasting has existed for 20, 30 years, right? But the problem has always been now with the new techniques coming in, can increase accuracy of forecast. Almost every single company is kind of saying, I have a forecasting model running for 25 years, right? I want to disaggregate it, increase its accuracy. So people are saying there are new techniques that are available, we can use some of them. Right? So time series is a very interesting area. Very, you can imagine, right? Every company, every transaction that a company captures is time series based. So obviously there is a lot of importance to it. So there are techniques around time series forecasting and how do you do it. There's an approach which I have provided. You can take a look at it. Right? There are a lot of things that have been done by framing the time series prediction as a regression problem and then accounting for all the different things and then solving a regression thing, right? It's not again the same way as we solved the previous regression. Here you use a certain kind of different techniques, right? You use the lags and the leads kind of stuff. Get the time series thing as a feature and then you start using regression kind of techniques. So that's another very interesting area. The third one is deep learning. So if you have heard of recurrent neural networks, right, RNNs as they say, RNNs has an architecture. I'm no expert on RNNs, but has an architecture by which it can basically understand that whatever the temporal structure of data, which means which is time series based or which is coming as a sequence. It understands the sequence because it has memory, right? So I mean, in some sense, it's trying to mimic the human brain. So how do all of us learn? We have a set of we have something around the memory part, right? We memorize something. But we also generalize, so that when some new thing is shown to us, we are able to take something from memory and then use the generalization to identify what that object is or what that thing is, right? So RNNs have that kind of a concept where it can memorize certain thing, it can forget certain thing, and the architecture basically enables that. And so it is used, I mean, it's being used in the time series forecasting at least quite a bit. So we have covered 3 categories, right? Okay. Now coming to the first question again in terms of data. What if it's unstructured? You've seen structured data, what if the data is unstructured, right? Then you're starting to think about, okay, if a label is present again, right? So it's let's say an image classification problem, right? Or I think I've given some examples, right? If a a label or something is present. Then the fourth category is you're still doing supervised machine learning because you're predicting something, some label, but you're doing it on unstructured data. So obviously the techniques have to be different. And so the difference here is that if your data is text, so if you have a bunch of textual data, or one of your attributes or some of your features that are there are text, which you also want to convert it to a feature to predict something. And so things like classic examples even. Yeah.
Is it social analytics you're talking about?
Yes. So, yes, social, but social also has two different parts to it, right? Social, if you're really predicting something, for example, the example of detecting sarcasm in tweets, right? It is social, but you do have some labels on which you can predict. But social can also be like, I don't have a label. Let me just tell me what are all the what are people talking about now? What are the emotional factors around people talking about a specific product? That's an unsupervised case, right? So there are two possibilities. Right? So email spam filtering is the most easiest thing to understand, right? So it is text. Your emails are text, and the spam filter basically analyzes the text to say spam or ham. Right? So if the data is text. So there are again multiple things. So text is something that is extremely interesting because all organizations have accumulated lots of text, right? When it comes to organizations, because of documents, contracts, etc. The social or the external data is all text, product reviews, the social media tweets. There's a lot of text out there, right? But how do you make sense out of that text to really use it for a prediction kind of a problem? Is a very interesting area because there are significant value add in terms of incorporating the textual features into predictions, but it's a slightly how do I say, involved field. People have to. But the good thing is, again, in the open source community, so being so active, you pretty much only need to understand what is the idea behind doing this. Doing this, somebody has really done it, right? So if you take, if you're a Python guy, there is a package called Spacey, right? Spacey basically lets you do everything. You just give one corpus of text to Spacey, and then Spacey will parse it, sentence it, it will extract entities, it will extract people names, it will extract organizations, it will tell you what are the phrases which are very important in this body of text, right? Spacey can do everything. But you still need to understand, okay, what is text pre-processing, right? So if you get a bunch of text, right, what in a text pre-processing scenario, what do you do? Why do you do stemming, right? Why do you want to remove the stop words, right? It's important to understand it. How you do it, that's fine. I mean, somebody has really done it. You just have to figure out who has done it. Right? So we are talking again category 4, which is about predicting something. So you will have to convert in a prediction scenario, right? When you come to text and you want to predict something, you need to convert the text into some kind of a numerical feature, right? In the recommender system, we spoke about the TF-IDF. That's one way of converting into a numerical feature, the term frequency goes down by frequency. Or you could just do a count vectorizer. So there will be multiple ways of converting a body of text, tokenize it, and then convert it to a numerical variable. And once you convert it to numerical variable, you're good, right? Because you have those are the features that you want to feed into your classification problem. If you want to classify something in the text code, right? But so how do you convert tokens to numerical values? What kind of machine learning algorithms you apply? That all goes back to your classification thing that we saw in category 1. But now we've got the features. But the difference here is how do you get the features is different. It's not straightforward. You need to do some processing. Okay. How much time do I have? I take another 10 minutes, 15 minutes. So let me run through this, right? So now we're still on supervised machine learning on unstructured data. What if your unstructured data is images, right? Image classification. Okay. Then what has happened is there is this thing called convolutional neural network, right? CNN. So anybody in deep learning would have definitely heard of it. There's so much talk and so much things there. CNNs. So people have been always grappling with this problem of images. Can computer vision, right? Can computer really recognize images? Research, if you go back, it's been there from 75, 76, 80 and all that. People had a view of how to solve that problem, but they simply didn't have the computing power, right? It was not really available. So what happened in the last, I would say 5-6 years is that really that architecture has been brought to life, and that architecture is what is called as CNN, right? Convolutional neural network. Can be used for many different things, but definitely for image processing, that is in some sense, the de facto standard right now. And how did they prove that? They basically took what is called an ImageNet library, set of images that are there. And then people have been doing this classification on top of ImageNet with different techniques. Convolutional neural network, and typically the increase in accuracy was like 1%, 1.5, 2% for years, for decades together. CNN came in, people tried using CNN on image classification. The increase in accuracy was in the order of 10, 11%, 12%. Right? ImageNet now accuracy, the benchmark accuracy is 95 or 96% now because of CNNs. Right? And so now it's kind of becoming mainstream. So anybody who wants to do image classification, right, is looking at CNNs in a big way to do it. It's a little involved to understand what is that architecture, what each of the layers in the CNN does. But if you understand neural networks, artificial neural networks, you can pretty much understand CNN with its own pluses and minuses and learning and things like that. So I will leave it for you guys. Probably CNNs could be another session which you can, again, I'm not an expert, but I've experimented with a few things. So if you really are a hands-on guy who wants to do this, I would suggest this. Keras is the package in Python. The Keras is an excellent package, which is a wrapper of sorts on top of TensorFlow. TensorFlow is Google's machine learning library, primarily for deep learning, but you can do other things also, which is being open source. So if you use Keras on top of TensorFlow, you have code, everything available through courses or notebooks written by people, where you can basically take it and apply on any kind of image processing problem. I'll leave it at that. So if it is images, you are basically looking at CNNs, a deep learning approach. Okay, now we have seen text, we have seen images, but what if it is temporal in nature, which means what if it's speech, right? It's still text in some sense, but there's a sequence attached to it. What about audio, right? It's still text, but then it's different because there's a sequence attached to it, right? So then that is where the RNNs come in, right? The recurrent neural networks. Where if it is kind of for speech and audio, if you are really looking at a prediction kind of a problem, the recurrent neural networks is probably the state of the art right now. Again, this is a very fertile area for research too, so by the time we complete this talk, somebody would have come with some other architecture. Right? But this is the state of the art, right? What if the label is not present? Then you are in category 5, which is unsupervised machine learning on unstructured data. Right? You are talking text and images, but you don't have a label now. Right? You're trying to understand the structure within the text. Right? So unsupervised machine learning on unstructured data, the data is text, the whole range of what is called as natural language processing or NLP applies. Right? NLP also applies in some way to the previous category that we spoke about, where we are processing text. But when you're talking about unsupervised machine learning, you're trying to get the structure within the data, and there's no label for you to really work with. You are really in the realm of natural language processing, NLP. Right? Fantastic packages available in R as well as Python. Python is NLTK, Spacey is another one. There are multiple things. So I will just leave with two things. One, when it comes to text, you want to understand the structure. You have to get you need to extract information from the text itself, right? So it is one, let's say it's a tree, or it is one sentence in a document, or one paragraph in a document. You are trying to extract entities and organizations, parts of speech and things like that, what is loosely called as language engineering. Right? Then the other part of it is you want to understand the relationship between all the things in that whole text thing, which is called the corpus. So if you put all your documents together, you are calling it as a corpus. And you need to now not only understand what the individual document says, you need to understand the relationship between the different documents, correct? In order to say, is this document about banking, right? Is this document about some regulation in banking? How will you identify all that, right? The beauty of the whole thing is there are things like something called LDA, right? LDA is an algorithm that helps you get to the topics within document. It is used in what is called as topic modeling, right? The most recent in the 3 years, right, is what is called as word embeddings, right? Word embeddings is again a very fascinating area because Google has basically developed it and Google uses it basically to understand. So when you type some search words in Google, it basically gives you recommendations what the next thing should be, right? That's all word embeddings, right? If you can think of word embeddings like, let's say you're given a corpus, right? You take let's say it's a fill in the blank kind of a thing, right? I want dash food tonight. Now the dash could be filled in multiple different ways. Right? It could be good food tonight, it could be Italian food tonight, Chinese food tonight could be filled in multiple ways. So word to vec is a way of saying what are all the words that is applicable in that kind of a situation, right? That is what word to vec does. This concept called word embeddings that Google uses. And so if you really look at how Google uses it, it's very intuitive, right? So when you type in, how do they get the next word to tell you that this is what you probably need to type? It's basically because in all the things, documents that they have seen, right? Their whole Google's corpus, as they call it, it's called something else. Google corpus, this is what they have seen as the predominant set of words that comes after this word, or comes after when two words are typed, the third word in the complete corpus of Google. Basically, the highest probability is what they show, and with decreasing order of probability, they start showing the other recommendations. So, intuitively, it's very easy to understand, but there is a whole algorithm behind it. Again, the beauty of the whole thing is variable equals call word to vec as a function. You will get the complete word embeddings in any kind of corpus. So, yeah, allow is another way to do this. So, I think we are in category. The thing is, images, I'm not too sure, right? Unsupervised machine learning on unstructured data. If the things are images, I really don't know what kind of techniques people use. So, that is something which I'm kind of investigating or figuring out what do people really use. Is there a use case for it? But I come across something called Boltzmann machine. So you keep hearing this, you go and check what the Boltzmann machine is. Probably it is in some sense relevant to it, but we need to do more investigation. I put that as a question mark because in some sense that is what we all want to do, right? We don't want to have all the answers at one shot. What we want is the question for which you need an answer, right? The answer will come over a period of time, as long as you are curious about it. So that is category 5. Category 6, again I'm not going to talk in detail because it's not something which I know very well, but you can basically take a look at it. It does have some theoretical views in terms of what this is. Category 6 is the whole artificial, what is called as reinforcement machine learning, or I put artificial intelligence also into it, because if you look at supervised and unsupervised machine learning, you're just dealing with some data sets. But reinforcement learning is you're dealing with the environment, right? So think of it like a robot, right? A robot basically has to walk around this, let's say this floor. It is basically taking a lot of structured data, it is taking an unstructured data, and it has to react to the environment because it sees something in the middle, right? So that is what is called as reinforcement learning, where the whole machine learning algorithm reacts to the environment, takes appropriate actions, changes its policies, and then basically gets the reward or achieves the goal, right? Artificial intelligence in some sense is like that, right? So it basically uses a lot of reinforcement learning because it has to react to the environment, absorb it, and take actions based on it, and constantly keep fine-tuning it. So that is category 6. Category 7 is nothing new, but now we are talking about, fine, I've done all this supervised machine learning, unsupervised machine learning, structured, unstructured, very good, but what if the data is web scale, right? I can't do it in one machine, I can't probably do it in this thing. So what do I do? So there's a whole aspect of scalable machine learning. How do I scale algorithms? Becoming very important because people want to use a lot of data. So it's one thing to prototype something in your machine or in a small Hadoop cluster, for example. But if you really want to scale it up, which is what the production systems need, you need to get into scalable machine learning, and that is where Spark and a whole lot of things that are there. So it's the same technique of algorithms, but how do you do it at web scale? Right? It's one thing to run logistic regression on 10,000 rows, or even your laptop now can take probably a million rows, so it's nothing more than that. But what if you have 1 petabyte of data? It needs a very different view. You cannot run it the same way. So that is scalable machine learning. There are again techniques and things like that are available. One important thing when it comes to scalable machine learning is the whole aspect of the cloud, right? In my view, this is my personal view, machine learning in the future will all be on the cloud, right? It simply doesn't make sense for me to do it internally if I'm really doing it at a production level web scale, right? So an appreciation of what cloud infrastructure could enable machine learning, what are some of the tools that are available, right? Amazon, for example, has a machine learning platform, right? That's web scale because you can just feed the data in, whatever, how much our data it is, it can do all your classification, regression, etc. As your machine learning does it on the cloud. There are specialized platforms like Databricks. Databricks is completely Spark, right? And it runs completely on the cloud. There's really no evolution and all. So category 7 is all about thinking, if I go to scale up, what techniques am I going to use to make it scalable, right? That's category 7. We have 3 more categories to go and I have 2 minutes. So that's fine. It's like a James Bond. Category 8, I just want to put this in because if you really think about it, predictions are one part of the story, right? But if you really want to take a business decision, the business has constraints. It's one thing to say your sales is going to be $50,000 next month. Fine, that's what the machine learning predicts based on whatever. But then what if you have a constraint and you don't have enough logistics support to actually get so much materials to your retail stores, right? You're probably going to lose out, right? So there are optimization problems in every single business decision. So it is very important to have a view in terms of how do you take a machine learning output, right, and add an optimization problem on top of it to really take a business decision. More often than not, you might have to combine the two, right? So take a media mix modeling kind of a problem, any kind of a problem, you have to finally say, yes, this is what it tells you as the budget, but based on my intuition, based on the business constraints that we have, we will have to solve for those constraints to arrive at the actual values that would help the business take a decision. Right? So I've just put out optimization there, basically to say this is there are multiple techniques and we can cover all of that stuff. Take a look at it. Right? But it's very important to understand that if you really want to make a connect to the business, right, you have to get the output of these machine learning algorithms into an optimization kind of a scenario or a platform for you to really take your decisions. So that is category 8. Category 9 is you've spoken about the different algorithms, you've spoken about how it scales and all that. There's an aspect of putting things in production, right? Which is very interesting because again a classic example is a recommender system, right? So recommendations are fine, but it has to have an interface, it has to get embedded within the process. Probably things like it has to get not recommendations, but let's say an order management anomaly detection has to get embedded in an order management system. So it has to exist within a particular system for it to provide the benefits, right? It has to exist in production, right? So there are multiple aspects to the software life cycle. There are architectural considerations. So as a data science person, you need to have an appreciation for the other parts of your ecosystem also, right? What are these web technologies? You might not be a web expert, but you should understand that this will reside in some kind of a web application for it to provide the benefit, right? What web application? How is it? Do I have APIs that are generated so that which the web applications can consume? Those are the considerations because now you are deploying things in production. It has to run in production. And that's the ultimate test, right? So I've listed a few things about the authorization of notebooks, hardware, GPUs, etc. You can take a look at it. But that's category 9, so we are coming closer. So what we have seen so far across these 9 categories is it's all about data, structured, unstructured, scalable, large scale data, and all the different techniques that are applicable. Some more, if you kind of go down, look at some of those things, it will give you some more insights into what are some of the techniques that are applicable. But now just the other 2 problems, what if the focus is the system, right? Then you are a little lost because now you have to think about the business process itself, correct? So category 10 is more system process focused insights, right? Category 10, if you look at it, there is something called business process simulations, right? So you can actually build a model of a system, right? Simulate data through it to understand insights. That is applicable in situations where people are saying, I have a system like this, I don't have enough data. So the classic case is what they say is a nuclear power plant, for example, right? You want to kind of model what is the risk of in a nuclear power plant. You will not get so much of data to do a machine learning thing there, right? You basically need nuclear meltdown data for you to model a nuclear thing. You might hardly have 4 or 5 data points like that, right? But you can develop a scenario, right, which is basically saying this is how the different pieces of the system interact, and these are the different distributions of data, and can I predict what the system state will be over a period of time, right? So you have a system view. And there's another fascinating area called probabilistic programming, which is called as Bayesian inference and things like that, which again deals with how do you look at it from a system standpoint and not as a black box, right? What are the kind of techniques that are there? The last category, the last one is also category 10 because these are the process focused insights. I've bunched system and process together. So the process focused insights, there is this area called process mining. So if you are in the business of dealing with business processes, please do take a look at this because this will give you all the things that is needed to get process related insights. So what is the bottleneck in the process? What is the typical path that a particular person goes through in the process? Things like that. Right? Okay guys, I think that's basically what I have. Those 10 categories across these different areas. And I'm very sorry, I think I kind of rushed through some of them. Probably just too much information. I just want to give you a perspective on multiple things. So that's basically what I have. It's available on the, I will send you the, as part of the PPT, right? Which you'll share the PPT. So I will send the PPT. So this PPT has 2 mind map links, right? So this original mind map, the big one, and then the next slide I have given this particular navigation mind map, right? It's available on that. You just have to.
So what program should I use to access?
You don't have to use any program. Just type the link in the browser. It's a mind map developed on a cloud platform. So you can just access it. You don't have to. So it's available on Data Science World. Link on it. You can keep clicking, and if you have any feedback, you have that feedback. And these are my
Any questions? Any questions?
I have a question, but I suspect it may be very basic. Basically, when it comes to data science, how we are now choosing the platform actually? I mean, kind of Microsoft is providing their own cloud platform for data science. Amazon is doing, and Google is also now they are also. How do we choose wisely in this? Among these platforms?
Again, there are multiple considerations. You're talking about a business setting, correct? Or you're talking about learning?
Both actually. For learning as well as it's in terms of technology, choosing the technology, and which is supporting the data very much.
Correct. So
there
this is what I would say. If it's for your own learning, right? You should probably choose between 2 platforms. One is a little more programming oriented, right? You need to anyway be hands-on at the end of the day when it comes to data science, right? Choose R or Python, which is typically the community is very big. I started in R, but I moved to Python because the community is much better. You get code everywhere. You just have to type. Your Google search becomes your most important this thing. You get code everywhere. So ideally choose Python so that you can learn some of these algorithms, have an intuitive feel on how it works and things like that. So that's the programming part of it, but not everybody are programmers in that sense, right? You also want to work with some platforms where you don't have to do too much of programming as long as you have some intuition for it. I suggest Azure Machine Learning is a great platform. It's drag and drop, it's GUI based, right? You have to just think of modules. You have modules available, pull it in, connect it, and it will work, right? There's something called BigML, right? BigML.com. It's again a fantastic platform. It's very GUI based, very intuitive, very simple to use. So that is the learning part of it, right? So I would say one solid programming platform plus a GUI based platform is a good combination to start with. You typically get the feel of it. In a business setting, the problem is a little more complex because it also depends on what the customer will be able to do. Does he have a platform, already existing platform and things like that? But one thing is for sure, most of them want to move to cloud, right? So it's good that we work with a cloud-based platform because that in some sense is the future of machine learning and doing all these different types of algorithms. That's one part of the story. The second part of the story is Python is good, but Python does not, or this is the opinion that people have, right, which I'm just taking that opinion, is it is not very good for production-centric environments, right? So you probably have to link it to a Java application because in a business setting, you see a lot more of Java. So either you can take a call saying that I'll work with a Scala. Scala is another programming language which integrates very well with Java, or use Java itself for machine learning. Though it's an overkill in some sense. You don't need really Java, but if you really want to integrate very well with your production environment, you can use a Java or a Scala. Python is doable. We do a lot of work in Python in our production setting also. So that's what I would advise. Cloud platforms, it depends. If they are a Microsoft shop, they'll be more comfortable using Azure, right? That's how you take the call. And if you're moving to an Amazon cloud, like most of the companies are, then it's a natural fit would be an Amazon machine learning platform. Does that answer this?
Yes.
So I had a question regarding this step 9, speaking about requirements.
Yeah.
your models and predictions which we are giving you, or a model we are giving you, will work reliably? Meaning what kind of test parameters or test driven approach will you take?
Your question is a little deeper, right? So one is about the software principles itself, right? Software engineering principles in terms of getting a system into production, right? So that aspect is the typical software life cycle, what is applicable. In some cases the DevOps could be applicable, sometimes Agile, sometimes waterfall. So that's one part of it. I think your question was more on the...
Just to clarify, if I had developed a model and I made it as available as a REST API, just simple JSON everything.
Correct.
But how would I do a test or give the customer a test, set of tests saying that okay, my model will work reliably because I tested it with these, this paradigm or this test-driven approach?
So that's a very good question. It's not there's no easy answer. So the first step in that process is to convince your business guy, right? The guy who is going to deploy this or allow you to deploy it in production, kind of convince him that this model is good because it basically looks at the right kind of things to make that prediction. So that's the first part of it. And typically the business experts in your company will have a good handle in terms of what the customers will probably like or not like, simply because of their domain expertise, right? But to convince them will take some doing, because if you're doing some black box algorithms, how do you really convince them that this is a good model, it picks the right features? Yes, it is very much applicable, it will not give you negative or false positives and stuff like that, right? So that is one part of the story, right, where you convince your business user to deploy it in production. In the customer scenario, right, there are again multiple ways of testing your models out. One way is take the feedback, right? Incorporate the feedback in terms of saying, okay, I suggested this or I predicted this, the customer in some sense said, no, I don't like it. You basically feed it back into the whole system, recalibrate the model, push a new model back, right? So that is one way of looking at it. The other one is what they call as A/B testing, right? So you can do some kind of A/B test to basically say you give two different, same predictions given out in two different ways, and you basically see what the customer is really preferring one over the other. And you have some statistical ways of figuring out what is being preferred one over the other. So at a very high level, A/B testing is another way of figuring out across your options which option is a better option to work with, right? But the overarching answer is you need to be able to get that feedback in some way, right, from the customer or from the user as part of your model, and feed it back in and recalibrate your models. Right? It might not be even direct feedback, because even transactional data, as you keep accumulating more and more data, your models will tend to become better. Right? Because
just to be very, very specific, meaning is there any frameworks associated with currently to test machine learning models that will be?
Test meaning interpret machine learning models.
No, as in if I deployed it into production and on a continuous basis, every few iterations I make some tweaks and I send it out. Is there any framework currently?
I don't know of any framework. Probably there is. I don't know. But these are basically APIs that are being sent out, right? So you need to have a mechanism to get the feedback, see whether it's right or wrong, feed it back into the model. Whether there's for example, there is a platform called Prediction.io, right? That basically helps you to build these APIs and then have this kind of feedback loop built in. Because that's a platform by itself. I don't know of any specific framework, but I'm sure there are companies like this. There's a company called Wise.io, which is focused on the customer services space. They have a fantastic product in terms of how do you automate customer servicing, and again take the feedback from the customer to keep improving the models throughout this, do this A/B testing to understand which are the things that you prefer. But yeah, if I come across something, I'll probably let you know.
You said like we have a list of models that we have, and we just input the data model.
Correct.
What is the use of it? Because each model will be built up based on certain purpose, right?
Yes.
So what is the outcome of it? What are the why are you saying it's a best fit putting your data for different models and then getting because as a user, as a developer or user, I should know that this data will be fitted to this model.
Yeah. So when I say the list of models, we are only using the models that's applicable for that problem. So if it's a classification problem, you use
regression.
yeah.
So I am putting into why are you saying like all the
Because that's, you have the metrics on which you're going to measure, correct? You have your RMSE or MAE or whatever metrics, correct? You have a whole lot of algorithms that are there. If you can pre-select and say, I will always use a linear regression with regularization parameter as L1. If you know that and it's kind of helpful in your context, feel free, right? But if you don't know that data, right, you never know which of these models will give you a better accuracy or better metrics on the test data set, on the training data set. You don't know upfront, correct? That's the reason. But you still select only a set of models. It's not that we run all the models. We select for a regression type of problem. Yes, linear regression is applicable. LDA, QDA is applicable, right? KNNs are applicable. So you select those bunch of models, you feed in the data, you have the RMSE as your overall score, right? And use cross-validation to figure out of these models, right? Which one is able to track the signals better or to understand the signals in the data better, right? Which results in a better measurement scores for you, the scoring thing for you. So that's the reason. But again, as I said, if you really know what works for you, you'll be using that multiple times in a certain situation, and it's always worked for you, you can just select one model. This is a way of saying, if you have multiple models to choose from, how do you choose it? Basically run it against this data set, look at a metric, whichever gives you the higher metric or beyond a certain threshold, you will say, this model seems to be working fine in this context, and you basically
the given model is actually stepwise execution to narrow down the best possible features. And across the models you keep applying and then use the metrics to compare against each other. Choose the best.
Because there are just so many models out there, you don't want to lose out in some sense, right? In some cases, a KNN would work much better. A support vector machine would work very well in a certain type for a certain type of data, a data distribution, so to say. So it's very difficult to really get that feel just by looking at that or visualizing or analyzing the data. So you need to do a certain level of pre-processing, get it to a normal thing, all the standard stuff, let it loose on all the models, applicable models. And since you have a metric to measure, you're comparing all the algorithms against that metric and saying, looks like these three things are better in this particular situation for the data that you are seeing right now. But you have a very important point, you need to be recalibrating. You cannot say, oh, for this data, these two algorithms are the best. Tomorrow some new data will come in which will negate.
In each model you can use the tweak the data, basically to achieve the most accurate, close to accurate, close to accurate, you can tweak the parameters and the
That is the parameter tuning, right? So once you select a bunch of algorithms, correct? Then you say, okay, here are two algorithms that are applicable or providing me the best scores for this problem. Okay? You take it to the next level and say, for these algorithms, let me tune the hyperparameter. Because the first step, you are using default parameters. You are only giving the input data set, okay, the input features, right? Then you are taking it down and saying, can I do hyperparameter?
9 models, algorithms, they'll take 1 or 2 and then I start reading the data and then go further.
That's up to you. If you have a big enough machine, do hyperparameter tuning, grid search for 9 algorithms, right? It's only that the problem is typically we don't have that much of leeway. So you might have to select a few of them beyond, okay, RMSE beyond a certain threshold or lesser than a certain threshold is what I will select to kind of move forward. If you have the muscle to do parameter tuning, then both of them are steps together, right? Give the input data set, have a grid search, do it for 10 algorithms and get the best algorithm. You can do it as 2 stages or as 1 stage.
It's also the ability, the compromise between the overfitting and the optimization ability of the model. And also, like, just to add to there are hyperparameters that we can do, and also the feature selection by stepwise execution and things like that. And also in terms of transformation, there are specific statistical techniques which can tell you which kind of transformation bringing in a given feature will help the model in a best possible way. So you can just look at that, learn that statistical technique, which will tell you if you bring in this feature in a squared form or log form or whatever, it will help you the model in a best possible way.
So in fact, that is also now automated, right?
Yeah.
You use a box transformation of the lambda parameter. You just keep the feature, it will tell you what the lambda value should be to make it a normalized distribution. You don't have to think. Give the feature to a box with the lambda, it will give you the lambda, use that lambda to transform your data. Right? So it's getting highly automated in some sense. You just have to understand why, what does that lambda signify? How does the box transformation, does it read something? But you basically when you are hands-on, just use that which is being done. You just need to know how to how to use it in some sense. That's
I think Azure ML, they give the option of comparing the models also.
yes.
So that is, we can execute all given the same set of features, run it through the multiple models and see how much precision it is, and you do a comparison of models and which is better, and it is always not a recommended one. 100% perfect is a better model.
Yeah, that's the overfitting problem.
Yeah, that's a little bit that goes with the business decision, like where I should start.
If the metrics are too high, then it means that there's something wrong either in the model or in the way the data.
So that's why we do k-cross correlation to avoid.
So I've listed some of them as part of this. I will not even go through all those details, but just that it's a fascinating area. It's kind of developing on a day-to-day basis. So once you get started, it's like a addiction of sorts. Anyway,
So in academic sense, put an hands-on experience on so when it comes to the production acts, so I would like to always having some memory constraint and so I can be able to make it in production. So I'm looking for some other programs, so it's very easy to production acts. What would you recommend?
I'll give you two answers. One, yes, it has a problem in production, but if you look at what Microsoft is trying to do, right? Microsoft has taken R and they have created a big production capable R on the cloud, right? It's called Microsoft R something, MRS is what. They have taken OpenR into a MRS. Revolution. After that, now they have created something called MRS, right? Which is their complete R thing on the cloud. Okay, and it's very scalable. They want more and more people to use it because it's highly production ready, right? So that's one way. So you probably need not leave R if you take a look at MRS and see that's good enough for you to deploy it in production. Right? If you want to come out of R and look at some other platforms, Scala, right? Scala, that is one platform that is getting a lot of money because Spark and many of these things are being written in Scala, right? And Scala is more like a functional program, has a lot of advantages and things like that. But the learning curve on Scala is very high, right? But they say that's the kind of future when it comes to deploying these kind of machine learning things on the production scale. But you never know these technologies, right? Scala, right? Python only expected Python to kind of grow so much. There's a community that started. So I would say anything with a JVM kind of a thing is a good thing for productionization, right? Java or a Scala which works on a JVM, right? Because many of the existing systems in our IT landscape are based on the JVM, Java virtual machine. So it is useful, but check out MRS because if MRS is there, you will not know all the VAR itself. Right? MRS could be a way of productionizing systems.
Just to add, so another way of staying in the context of R and using production there is a simple PM model. You can look at predictive model markup language. So you can predictive modeling markup language, PM model. So you can develop your models using R and then export it using PM model. It will give you a form of XML which you can put into other form of things like in Spark ML there is a support for PM model. So if you export your model using PM model and deploy it in Spark ML, then it can do your scoring runtime on a scale, right? You can develop your models in sample data on whichever the amount of scaling that you can achieve using R, and export the model using PM model, dump it into your production system which is running in JVM. Then it can do your scoring at real time for in scale for the volume of the part that you're doing. So that's also something that is.
But have that category in mind on how you deploy it in production, you will find an answer. Let's see data.
Since we're talking about deploying into production, you said Java and Scala are good options. However, there is another option of using Python itself by Dockerizing the Python application. Is it comparable to Java and Scala in production?
It's a kind of there's no right answer to that question, right? I believe that yes, Python will be an answer to it. So what is really happening also, right, is that many people, so there is this debate about whether to use the JVM or not use the JVM. Google, for example, does not use the JVM. They moved away from the JVM saying that JVM is the bottleneck for me to run machine learning algorithms at scale. Okay, I need to interact with my hardware directly. Okay? if you have to interact with the hardware directly, you need probably Python with a hardware kind of integrator. There's something called CUDA, and stuff like that, which can help you to really interact with the hardware, and you can actually do things in scale. Dockerization is a great way of actually containerizing everything and then running it in scale. But JVM has its own benefits, because JVM's thing is you write once and you kind of run it everywhere, right? If you are in that kind of a paradigm saying, I want my code to be completely portable, right? I'm not going to interact with your hardware at all at any point in time. Then a JVM based approach, if that is what you are taking, Java and Scala are the options that are primarily out there right now. But Python is very much possible. There are big companies that are running Python using Dockers. I think Quora or somebody uses Dockers to basically manipulate with their Python. So very much possible, yes. I hope it is going to be Python, because then it will be relevant.
I use this talent. So they are giving something like component pricing, much similar to Azure, like some drop.
To do machine learning?
To do machine learning. They cover like ETL and big data.
Correct. Talent has been an ETL big data kind of a platform.
They are having the machine learning as well. So where we can do much similar to the Azure analytics, the components and the parameters and get output. It uses the JVM. We don't need to write Scala coding and all. It does it for us.
It generates
the code. It creates the code and gives us a jar code.
And jar is another thing. People are very comfortable deploying jar files in a production environment. They know how to work with jar files. So anything that creates a jar file, they're very happy. So we need to work around all these different things.
What is your idea about this data science platform? Like, you have DataIQ, data rover, Datascience.com. It seems like what it has right there, I can just give it my data. It runs all the models, like virtual models, again, and then
Big ML is one such platform, right? So my view, right? My view is that for certain types of use cases, I think those things are good enough. For example, if you really know what problems that have been there for a long time, right, and you kind of know how to solve those problems, there's not too much variation to those problems, right? I think these platforms are probably the best. Right? You don't have to really create many things, but there are going to be very unique problems for specific customer situations, right, or custom business context, for which you need to customize a lot of things. You need to have a very custom developed machine learning platform. Let's say you're doing image recognition, say for the insurance company, they do some image processing, do something, right? You really can't use this platform straight away to do those or to solve those unique use cases. So I think in an organization, it will be a mix of two. Simple use cases are standardized. I won't say simple, standardized use cases will probably use some of these platforms, GUI kind of things, where you don't have to spend much time thinking about it. All it needs is to run at scale and give a good prediction. But there are going to be definitely unique problems. If you want to do text processing to understand some text and all that, I don't think there are platforms out there which are very good as compared to what you can do with these packages. You can do some really wonderful things. So it's a question of custom built machine learning vis-a-vis some standard machine learning, and there's going to be a hybrid in an enterprise environment.
now everybody will come into automation, right? Like I think H2 as you know, like every one of the
So I think it's going to be a mix. In a business context, I think it will be a mix of different things. As I said, standardized vis-a-vis very unique use cases. But as data scientists, it will be good to know, at least be an expert probably on one and appreciation for the other. Or if you have, I think that will be good to solve, because ultimately you have to generate those use cases, right? You need to go to a business guy and say, data can help you solve this. Right? How do you kind of convince them that this is the problem that we solve? So, yeah, to your point, I think that will also definitely develop in a very good way.
So depends on the way production is going. If you are talking about, let's say you're building you just need to build a registry from whatever data that we have. Then productionizing is up to the client, where they just have an existing system on which they just implement the rules, what they promote in the business. Right? So that's one way where you can it's like a service that you are providing. You just throw data to some of these platforms, which comes out this model, but productionizing is up to the client. But if you are trying to inherently build your machine learning system in the existing system, then this platform will not be able, because if at all they come up with APIs and other things, right?
All of them have APIs.
Yeah, some of them.
It's all API first. Most of these cloud-based
But
platforms.
sometimes the integration will become an issue. You find it really hard. In that case, it's better you go with some sort of libraries. That is something, that's something that you can invoke from any other system. So that will be better.
So, one question regarding NLP. Do you have any recommendations for say context-based text analysis, like based upon some questions, the responses could be positive or negative? If you do normal text analysis on top of it, you might end up having all those vectorization and stuff like that, but you might miss the context of what was the question, what was the response.
Yeah, correct. Contextual search is a big area, right? So the word to vec, right, is one way of understanding the context within a corpus of text, right? So some of the interesting things that are possible is if you can integrate your similarity, right, across this corpus with a search platform like Elasticsearch or a Solar, right? Elasticsearch and Solar has its own way of indexing different types of documents to come out purely from a search angle, right? This concept, the word to vec will give you the similarity across the concepts. So if you can integrate the two, right, then it could become a. Have you tried this word to vec kind of models?
Yeah, we're using word to vec.
Okay.
But still, unless you have the training data which has that kind of combinations, you're not able to predict if it is out of the training set. You're not able to generalize it actually.
Topic modeling and stuff like that could probably give you some certain topics around which you can do something.
Topic good for classifying the documents, but when it comes to sentiments on the topic, it makes it very difficult actually.
Yeah, I mean that's because in some sense the whole language processing is the last frontier, as they say, right? You can understand language and make sense out of it. Then I think machine learning is all set.
So one thing actually you can look at is something called aspect-oriented sentiment analysis. So you can, whatever sentiment analysis that you are especially using NLP, right? You can do a sentiment analysis on a keyword basis. So if you are doing a backward technique, with the overall document corpus size, what is the overall polarity of the document?
Yeah, that's what we recommended. But
so step by step from there you can move. If you are using NLP, then you can do a keyword-based sentiment analysis. What is the sentiment of this document on this particular keyword? Let's say you are talking about restaurant review, right?
Yeah.
You can say that the quality of the food was good, but the cost is really high.
Yeah.
Okay, so here the sentiment that you can talk about, if you are talking about the quality of food, which is positive, whereas the cost is negative, right? So from this keyword-based sentiment, you can move to aspect-oriented sentiment analysis, where you can group these keywords together to form a set of aspects. Like if you are talking about taste, food quality, so these are aspects about the food. Whereas if you are talking about the lighting was good, the atmosphere was good, the service was pathetic, and things like that. So if whatever you are talking about lighting, the artistic look, there is a candlelight dinner available. So these things form the atmosphere of the aspect, right? So similarly, so like this you can group the keywords together into a set of aspects, and you can aggregate these keyword specific sentiments into the aspect, right? So you can come out with these aspects, this keyword to aspect grouping, either using topic mining, or you can sometimes based on business context and domain intelligence, you can apply them. Like once you come out with all the keywords, right? Let's say you apply NLP on set of review documents and structured data, you come out with all these nouns and other things which are considered to be the keywords. Then your objectives are all the sentiment indicators. So you group these keywords to these things. So at the first level, then you group these keywords into aspects. Right? Then based on the aspect, then you can aggregate the sentiment with an aspect. So that is something that you can.
So the keywords like we have to create it, or it's there.
No, that's it. If you apply on NLP on top of unstructured review, if you use the keywords to target, then it can automatically identify the nouns and verbs which could eventually become your keywords. So you can look at all the keywords, and that would come from your nouns and verbs and all these things. And the adjectives and adverbs will become your sentiment indicators.
Okay, the sentiment indicators will have some values. The word there is more mentioned like good, so it will have some positive impact. So So the words like bad and some of those negative sentence, then it will create some bad.
It depends on the context also. To which keyword, which sentiment, adjective, right? So if you say cost is high, it's an adjective, whereas the service quality is high, someone right? So then it means it's a positive. So depending on which context and which keyword, you have to say whether it's a positive sentiment indicator or a negative sentiment.
So those indicators will be created by us, or
There are multiple ways, right? There are dictionary-based things also. You can create a dictionary of sorts. So, for example, if you're trying to find out the emotional drivers, right, in a specific set of tweets, the emotion as well might not be present in the tweets, right? But you could say, if you see these kinds of words, right, then it means emotional thing for me, and then look for such words in the corpus. You can create a dictionary-based approach.
Affin data set is what? Affin data set.
Affin data sets, yeah. So there are multiple techniques. Yeah, the way you can get it out of the text itself, or if you want, so you could go to some other websites, scrape all that related information, try and see whether this particular corpus has those words, and then start fitting in the fact that okay, this particular tweet or this particular sentence has this kind of an emotion, this kind of a function attached to it.
Speaking of aspect level sentiment analysis, are there any tools currently that have implemented aspect level sentiment analysis? Maybe tools or libraries that have aspect level sentiment implemented?
I'll share some papers which talks about this aspect of analysis. But the technique as such, right, if you apply NLP and if you can extract the keywords and then the sentiment indicators using the keywords tagger, then you can do the keyword level sentiment, right? From one level, like from the polarity of the document, you are moving one level up to your keyword based thing. Then you have to group these keywords into aspects. So that's a thing whether you can do manually using your domain intelligence and based on your corpus of all these keywords, whichever scales you have to do, or one way is to look at topic modeling, where the group of words are coming together in a topic, and based on that, all of those topics becomes your aspects. Right? So then the keywords to topic are the aspects. Again, you can do by looking at some algorithms or by applying some manual iteration.
I was thinking like aspect level sentiment analysis is currently also a hot area in research.
Yeah.
Even the state of the art is not so high. That
I don't think there is a ready-made package available. Yeah, it's struggling for that.
Even I'm looking into it sometimes.
Because your problem is all the more interesting because it's question answer packs, right?
It's kind of a review based upon your surveys, right? If you say movie, the question is the movie good? If your answer is yes, then it's a positive sentiment. If the movie bad, still if the answer is yes, it's a negative sentiment. Okay, so you're not able to base on sentiment based upon responses around. You have to dive into the question, and also 100 questions for the same movie. Okay, so you have to find out.
There was a podcast by this guy, Quora's CTO, right? I think he spoke about this problem and how Quora solves this problem of doing this question-answer based pairwise sentiment. I forgot the name of the guy, but you should be able to see it in Stitcher or something. Sorry?
What was the name?
Quora. His name I forgot. It's a Spanish kind of a name. He's a CTO of Quora.
Quora. Okay.
He had probably 3 months back or something, he had a podcast where he explained what are the typical problems in Quora which they are solving by machine learning. And I think one of the problems is about this. How do we relate question answer pairs with respect to sentiment, with respect to their problem is more about this thing, keeping the bad guys out kind of thing, right? Who is writing bad about on a particular question, right? So that they want to weed out those people, and so he was talking about more from a health of the community as such. He spoke about this. Probably you would have, I don't remember any techniques, but you can probably take a look at it because it seems to be on the job problem for you.
It's simple and standard, but
There is a casual competition also for us duplicated examples. Put up a data set. There are people who are on the professional solution.
so I'll take that. Thanks.
That's also a very good.
Thanks, Karthikeyan. Thanks everyone for coming on the Saturday, spending your time with us. Probably next month we'll have a much more interaction, like working session. Because last 2 months we had kind of a theoretical. This month we are planning to have something like a working session where you can go do some hardcode coding also. And I'll pass on the slides to you. If you already signed up in the meetup group, you will be getting the slides. And if you have any other suggestions like how to improve this meetup, you're always welcome. Thank you. Thanks everybody.